All right, welcome everyone. Let's get right into it. Think of this less as a review and more as your strategic playbook for the upcoming quiz. We're going to connect all the key concepts from sessions 8 all the way through 14 and really turn that list of topics into one single, powerful strategy.
So here's our game plan for today. We're essentially going to walk through the entire life cycle of a real analytics project. We'll start by picking our lineup of models, then we'll tune them up, figure out how to keep score, and finally, we'll choose our champion. It's a framework that's really going to help you lock in these concepts for the quiz.
Okay, so first things first, let's establish our playbook. We're moving beyond just memorizing a bunch of definitions. The goal here is to build a mental model. You know, a step-by-step strategy that you can use to solve pretty much any analytics problem, whether it's on the quiz or out there in the real world.
And that strategy? Well, it all starts with this fundamental question that drives everything we do. You're handed a business problem, you've got the data to solve it, so where do you even begin? Well, the very first step is to know your team of potential players, the algorithms themselves.
So, let's meet the contenders. This is going to be a quick, rapid-fire introduction to the 4 key models you absolutely need to know. And we're going to use some really powerful analogies to make sure their core ideas stick in your head.
First up, AdaBoost. Imagine you're putting together a team of warriors to fight some big monster. The first warrior goes in, tries their best, but makes some mistakes. Now, the next warrior doesn't just start from scratch. No, they focus specifically on the errors the first one made. Each new warrior learns from the last one's failures, creating this incredibly powerful, sequential team. That's AdaBoost.
And this quote it nails it, doesn't it? It perfectly captures this whole idea of ensemble learning. You don't need one single, perfect, all-powerful model. Instead, you can get incredible results by intelligently combining a bunch of simple, imperfect ones.
Next up, we've got Random Forest. Now, if AdaBoost is a team that learns in a sequence, think of Random Forest as a massive committee of experts, and they're all voting at the same time. It builds hundreds of slightly different decision trees, and the final call is just based on a majority vote. This wisdom of the crowd approach makes it unbelievably robust, especially when you're dealing with messy, complex data.
Now for the Support Vector Machine, or SVM. The way to think about an SVM is that it's on a quest for the perfect divider. See, it's not enough to just separate 2 groups of data. It wants to find the one boundary that creates the widest possible street or margin between them. This focus on maximizing that margin makes it a really confident and powerful classifier.
And finally, the neural network. Honestly, the party analogy is the best way to get this. Imagine you show up at a party. You gather inputs, the music, the food, who's there. Then you process that info through these hidden layers. Think of them as your friends who all have different opinions. Based on all their feedback, you make an output decision. Stay or go. The network learns by getting feedback on these decisions, so it can do better next time.
Okay, this slide right here, this is your ultimate quiz cheat sheet for the models. It connects each algorithm to that core analogy we just talked about and its key strength. Seriously, I'd pause here and take a screenshot. This is your go-to summary.
Okay, so we've met our contenders, but just using them with their default settings, well, that's like driving a race car that's stuck in first gear. To unlock their real power, we've got to pop the hood and tune the engine. And that means we need to understand hyperparameters.
And the best way to wrap your head around this is to think about baking a cake. Hyperparameters are the recipe. They're the settings you choose before you start, like the oven temperature and how long to bake it. The model parameters, well, that's the cake itself, the result that comes out after the learning process is done. You control the recipe, the model bakes the cake.
So why do we even bother with all this tuning? Well, there are 3 huge reasons. First, it flat out boosts performance. Second, it helps prevent something called overfitting, which is basically when your model just memorizes the training data instead of actually learning the patterns. And third, it just makes the model more stable and trustworthy out in the real world.
So we've got our tuned model, and we're ready to see how it did. But how do we actually measure success? You've got to be really careful here, because the most obvious metric, accuracy, can be a complete and total trap. So you run your model and bam, 99% accuracy. Incredible, right? You're a genius, time to celebrate. Well, not so fast. That beautiful number might actually be hiding a complete and utter failure.
Think about it this way. Imagine a factory that makes 1,000 parts, but only 10 of them are defective. If your model is lazy and just predicts not defective every single time, It's going to be 99% accurate, but it completely failed at its one and only job, finding the defects. This is the classic example of why accuracy can be so misleading.
So instead of just looking at overall accuracy, we have to get smarter. We have to ask about the types of mistakes our model is making. This leads us to this classic trade-off between precision and recall. Is it more important to be right when you predict something as positive to avoid false alarms? That's precision. Or is it more important to find every single actual positive case to avoid missing anything? That's recall.
Now this slide gets to what is maybe the single most important lesson here. Choosing your metric is a business decision, not a technical one. For something like health screening, you have to prioritize recall because the cost of missing a diagnosis is catastrophic. But for a marketing campaign with a tight budget, you'd prioritize precision to avoid wasting money. For something complex like credit risk, you might need a more balanced metric. Remember this for the quiz. The business context always determines the metric.
Let's make this crystal clear with a quick case study. We're going to see exactly how a clinic's business goal for predicting diabetes directly shapes the entire technical strategy.
Look at this. The clinic stakeholders didn't give us some vague goal like, make it accurate. Nope, they gave us a hard, non-negotiable target. They know that the cost of a false negative, of missing someone who actually has diabetes, is just way too high. Their mandate is clear. The model has to find at least 80% of all the real positive cases.
And just like that, the business goal becomes our analytic goal. We are no longer just building an accurate model. We are now on a very specific mission. Build a model that can achieve a recall score of 80% or higher. That single business requirement dictates everything that comes next.
Okay, let's bring it all home. We have met the models, we know how to tune them, and we figured out how to pick the right scorecard. Now, let's put it all together into one final decision-making framework.
This table really summarizes the core idea of the entire playbook. There is never one best model or one best metric. The right choice is always a function of your specific business needs. If you absolutely need to explain the model's logic, you might pick a simple decision tree. If you cannot afford to miss a single positive case, you tune your model for high recall. Your business objective drives everything.
And that leaves us with a final thought as you head into your quiz. We're learning how to build these incredibly powerful tools that can give us amazing answers. But the real challenge, the next step, isn't just about getting the prediction right. It's about building systems that we can actually understand, explain, and ultimately trust. Good luck.